Okay, so today we are trying to not learn anything new from the programming point of view, but to put together what we already know in order to enable us to create or define the architecture of these client-server applications that are our target. Okay. The idea is we have a problem. We have a web application which is running on a client, on a browser somewhere. We'll learn starting next week actually how to build an application on the front end. But we know it will be an application running in JavaScript inside the server. On the user's computer. So on the user computer, actually, we have no resources there. Okay, we have browser, we have the application that runs inside, but we cannot store any data, any information. We cannot read or write any files. We cannot access any external resources and so on. There are a lot of security blocks in what the JavaScript code can do inside the browser. Just for safety. You don't want to visit any random website and having that JavaScript from that website delete your hard disk or worse, stealing your data. Okay, so what inside a web browser, what the JavaScript application can do is quite limited. Okay, can interact with you, we can interact with the web page, but it cannot interact with the rest of the application. And so all the, for example, all the persistent data, when you log in and you create a new account, where is this account information stored? On the server, surely not on the client. Where you are sharing some information with other people, this information must be stored in the server, so that many client applications can connect to the same server and share the data and work together. Okay, so the real data, all the persistent application data is inside the server, the database. So what we did last time, we tried to create a small web server that manages some information into a database, actually is the starting point. Okay? All the information relevant to the application is stored in the server. All the interaction with the user is managed by the client. And these two are in two separate parts of the world. By the way, normally the server is one for everybody, and the client is one for each client. So there's a one-to-many or many relationships between the server and the data it manages and the number of clients that need to access and manipulate and modify and read and write this data. We cannot. So there's an issue of being in two different parts of the world. There's an issue also of security. We cannot imagine letting some JavaScript code in the browser here manipulate directly the data on your database. Just imagine if there's some code into your browser could do a query, an insert, or delete on a backend database. Okay, they would destroy any level of security. And just because code running into a browser cannot be trusted, because everybody could hack the browser, modify the code, and run it a different version from what we have. Okay, so we cannot give this. The client application must have access to this data in some way, in some controlled way, through an intermediate layer, this question mark that we have here. So today we are thinking about one possible way of implementing this question mark that allows client applications, front-end web application, to access and manage some data in the backend, or maybe some services, some logic that lives in the backend. So what we are, and the other issue is that we must do this in a way which is compatible with existing web technologies. Because between the application and our server, this dotted line is everything. It's the internet, the public internet. It can have filters, can have proxies, can have NATs, can have antiviruses, so I can have a lot of things may happen that prevent me from maybe directly connecting with the database. There is one protocol which is always let through all kind of filters, databases, caches, and so on, which is HTTP. So opening an HTTP connection is normally always possible. Opening a connection of any other protocol may be blocked by your local network, for example. Okay? So everything must be done by using HTTP or HTTPS, of course, okay? Which is just an encryption layer on top of that. So we have a goal is finding an architecture for integrating a client and a server application. So it's an architectural pattern, but the tools that we have must rely on a protocol which is 30 years old, which is HTTP. Okay? So how do we solve this? There are a couple of steps. First is how can we transfer the information, represent the information? We don't want to give to the client direct access, but not even direct knowledge of how we store the data here. We will need to send some data from the application to the server, create a new user, post a new message, set a score on an answer or a question that we had in our toy application, and so on. So there's some way, we must find some way for the application to send data to the server, and on the other hand, to receive data from the server. Okay? Because all the data is there. The source of data is always on the server. So we must find a way, a general way, as much as possible, a general way of encoding all kinds of information. And this general way today is JSON. I mean today because maybe 10 years ago it was XML. So things may change. But in a way, we have the consensus of having some neutral format for representing data, also complex data. So normally, we think that every object, user, and you remember we did an exercise with a class, 3 classes called user, question, and answer. They will be objects in JavaScript, and content of these objects can be encoded, can be represented in JSON for the purpose of transferring them from the client to the servers and vice versa. So we have an encoding, a text encoding of the JavaScript objects. And this text encoding so that it can travel easily inside the HTTP request body and the HTTP response body that we played with last time. So the first problem is solved. How do we send you the data serialized into JSON format? And then, on the other side, reconstruct it, of course. The second point is, okay, but on a database, I could do many things. I need to insert new data, to run queries, to update, modify, and so on. Okay? So, can we find a general way of representing the operations that we can do on the data on the server side? Actually, we must split this sentence in how can we find a general way of representing the data in which we want to operate, split from the operation that we want to apply on those data. So the first step is, without giving you access to the structure of the database, how do I represent the data that is actually stored in the database? Let's say the information that is stored in the database. And the solution is just to use URLs to represent data. So we will, okay, if we have a question in our example, a question object stored into the question table in the database, today we decide a way of encoding a URL, an address, that represents the list of questions. Another URL that represents each of the questions. Question number 7. So for identifying data, we map the knowledge of this data into syntax for URLs. So that is how we represent data. And what are the operations? Sorry, I'll go back here in a moment. For representing operations, so once I have a way of representing questions, I have the operation of add a new question, or give me the list of questions, or delete the last question, and so on, or give me the details for question number 27. These are all operations that we can do, and we map these operations into the HTTP methods: get, post, put, and delete. Okay? So we have these 3, we are exploiting, these 3 levels of degrees of freedom, actually. How to encode data, how to represent information, and how to represent the operation that we need to do on this data, which is through HTTP verbs. So this is what normally is called the HTTP APIs, or somebody calls them REST APIs. REST stands from representational state transfer. It came from a PhD thesis of the person who proposed them. And actually, it's not a real standard. It's a loose standard. Okay, you can implement it in several ways, but it's at least a design principle, so that we can have an ordered way of thinking at this problem. The slides I skipped were basically describing the first 2 steps here. So the encoding in JSON of the information, which is actually quite easy. The whole specification of JSON is just 1 page. No? It tells me that a JSON is a text document that can contain strings, numbers as primitive data. So strings are just strings in double quotes, and numbers, we know what they are. And we can build complex data structures by creating arrays, which are delimited by square brackets. Sorry, the slide is small. Or objects, which are in braces with a key, colon, value format for every object. So exactly the same syntax that we use in JavaScript to create objects is the specification of JSON. In fact, JSON stands for JavaScript Object Notation, with more limitations from the syntax point of view. Basically, the most important limitation is that strings must always use double quotes, and the keys for the objects must always be quoted. Okay, so name, colon, Fulvio must have name in quotes and also Fulvio in quotes. Okay, you cannot just drop the quotes there, and also you cannot drop the comma, so, or add an extra comma for the last element, and this creates a lot of little syntax errors when you, but anyway. So this is an easy format to dump JavaScript objects into, and to reconstruct an object from a text file. And of course, this syntax can be nested. So I have an object that contains some fields. You see the quotes that are needed here in the keys names of the objects, that in JavaScript they would not be needed, but in JSON they are needed. And of the possibility of nesting, so we have an object with another object inside, or with an array. In this case, it's an array of 2 strings inside. So we can represent objects which also have some degree of complexity in general. Then we will have to decide, if we have an object that contains or points or refers to other information, whether I want to include it. How far should I go into including all the nested information into the representation? That depends on the application. It depends on what we need. So it's not a one-way choice. And in JavaScript code, in the standard library in JavaScript, there are two methods for converting an object, a JavaScript object, into a JSON string, into a string formatted in JSON, and vice versa, to read a string that contains a JSON representation back into an object. Okay, so it will be stringify and parse. We used implicitly through them last week when we were using the methods inside Express that, okay, we don't call these methods explicitly, but the response.json method will call internally a stringify. And when we were reading request.body in JSON, internally, of course, it was parsing this JSON method. Okay, but if we need to do this conversion in our code, these methods are just there. And then about the stranger things, using URIs to represent objects. So let's imagine an abstract view of the data contained into a database. Okay, a database is made of tables, rows, foreign keys, and so on. Many-to-many tables for managing many-to-many relationships. We know the structure of a database. Okay, but from the point of view of the information that is stored into the database, we tend to separate the information in two broad classes: collections and items or elements. Okay, so when we're talking about the users, in general, it's a collection of users, and a collection contains many individual users. Each of them, of course, it has a structure, a user name, an email, an ID, and whatever. Okay, so we define a schema for representing collections and for representing items inside collections. And this schema is just a way of identifying them. Instead of saying, okay, table users, the SQL table called users, we define a URL, actually, that we call /students, for example, or /courses, or /users. So we map every entity, every high-level type of data. We don't need to match each database table. In most cases, probably there will be a one-to-one mapping, but we are not forced to. We're interacting with a server that provides the way of managing questions and answers. So I will have an entity called questions and an entity called answers. Since we have many questions, I have a collection that contains all the questions and a collection that contains all the possible answers. And I have a URI. Whenever I want to talk about the questions, I will have one URL that represents them. A URL is just a string, okay, written in HTTP using the HTTP syntax. But for us, in this phase, it's just a string for identifying specifically that collection of information items. Then we have other strings for representing a specific item inside that collection. And the convention is that for identifying a specific item inside the collection, we use the URI for the collection / an identifier for the item, so the primary key of the item itself. So this represents a single student in this case. So the format normally is you have a prefix, of course, that decides where this information lives, and / collection for a collection of objects. Normally, there are names not verbs, in the plural form, not singular. That represents, okay, this is a set of students, set of courses. And for representing each of them, we just have the name of the collection / the identifier of the single item. So we have a string that maps normally to a row in the database, in this case. And what can we do on these objects, basically on these names? We can add a new item to a collection. If I have a collection of questions, I can create a new question. I can modify a question. I can delete one. I can retrieve the information about one question, or the list of all the questions, or the list of all the questions that match some criteria, so all the questions for some user, and so on. And so we must also encode not just the representation of the object, but also the representation of the operations that we can do of them. For example, when we want to get some information from a server, we use, of course, we need to do an HTTP call, and we use the get method of HTTP. Get returns some information, and what is the information? Well, if we are calling get on a URL that currently represents a collection, it returns a list. If we are calling get on a URL that represents a single item, well, that will return the representation of that item. Just to make an example, to be a bit clearer, let's say, okay, let's say some examples. On our toy exercise, where we had the entities that we want to work with, there are three. We had user, we had the question, and we had answer. Okay, that was the database that we had last week. Okay, answer, question, and user. This is the database level. Okay, and we want to allow a server to offer the possibility for client applications to manage and interact with this data. So all the high-level entities are these. We can define represent them using a URL like HTTP, something like that. It would be localhost, I don't know, 3001 or whatever, where our server is running, slash maybe API, slash version 1, some prefix. That would be always be the same. An address where our API lives. And then after that prefix, that will be always the same, we have the representation of the information. So the users will be inside the user's name. This is just a name, okay? Normally, by convention, the tables in database tend to be singular named, and in the API, they tend to be plural named. And in this case, the questions would be mapped to the URL, the same stuff, slash questions. And the same for the answers. Okay? Okay, so this is just a string, but this string happens also to be a web address. And on a web address, we can do calls, HTTP calls. We can send HTTP messages. So, for example, what can we do with how can we interpret an action like that, get on the first use, on the first URL? So we have a URL that represents a collection, and the get method applied to that collection object. So the action will retrieve the list of all items inside collection users. Encoded in a JSON format. Of course, that's what we decided before. So, if we have the permission to that, of course, you cannot just think of sending an HTTP call to a random server and expect that the server will dump to you the list of all the users registered in their website, okay? Including the passwords or whatever. This the specification of the operation, then we have all the checks to do whether it can be or should be actually executed. So the idea is that if I call this on the server, I need to implement my web server so that when somebody calls that URL, it will do the query and return some JSON representation of these objects. And there are a lot of degrees of freedom here also. Because what does it mean to have all the items inside the collection? Well, one possibility could have returning an array of user IDs. In our database, we have ID, sorry, the user was ID, name, email. So the IDs were 1, 2, 3, 4. So the ID, the one example, one option could be to return something like an array with 1, 2, 3, 4 inside. That gives me the list of the users. That doesn't give me too much information about each user. The minimum amount of information. I know there are 4 users, I know what are their IDs, their current IDs. Or I could decide that I want to have a more thorough answer. Option 2, return an array with the full representation of users. So in this case, it would be much longer. It will be still an array with 4 elements, but each elements, they would be objects. So each user would be represented by an object, and every object would contain possibly the full information for a user. So ID 1, the fields were that name and email, name Luigi De Russis, and the email would be this one. Let me cut and paste. With quotes. And then we have object number 2 with ID 2, name. That would be, okay, let's make it short, okay? Name was this one. No. I didn't copy it, okay. And email could be this one. Copy and maybe paste. And so on, okay? We have the other 2. So there are 2 possible implementations of the same functionality. In both cases, we are honoring this definition. Retrieve the list of all the items. We are just giving different amounts of details or different amount of information about each of the items. In the first case, we are giving the minimum information. In the other case, we are giving the maximum information. We can do everything in between. Okay? That's our choice. Depends on what we need to do. as long as we are designing and documenting what we are doing, what the API will do. Okay? In the second case, we have all the information available right now. Maybe we don't need all of it at the same time, so it's a waste of resources. We are transferring much more information than we need. In the other case, we are transferring much less information, will be more compact, but then if we need to do something, we need to probably ask for further information. Maybe I need some, okay, this is the list of users, I need to log in, or I need to show the information about the profile about user number 2. So in that case, I would need the information about user number 2. So what I could do in this case is to use again the get method, in this case on a resource of type element or item, like that. So if 2 is the identifier of an element of type user, this URL represents that user, which is Marco Zeta. So in this case, this get will retrieve the JSON representation. Then we drop with, it's always in JSON, okay? So after the first time, we will not write it anymore, of the properties of user with ID of the user with ID equal to 2. So we are embedding the identity of the object inside the URL. And with a get, we are asking for all the, in this case, the result could be, will be a JSON object. Not an array, because we only have one object to return, so actually would be this representation here. Okay? So in this case, I can get the list of the IDs and then pick, okay, give me the information about this specific one. It requires 2 calls for get the same information, but it depends on what you need to do. Probably if you want to show the profile of some users, you are only needing them one by one, so you don't need them all of them at the same time. If you are showing the list of answers to a given question, you need all of them at the same time, at least the titles, for example. So there may be different levels of granularity, different levels of details in the same call. And this also gives us some design criteria. We could decide, for example, that in our website, which is just an example, okay, we make our own rules inside this general framework. That by default, the get of the users will only return the IDs, maybe. And if we want the full representation, maybe we can use a get everything slash users. We add an option, maybe. No? We use the query string capability of URLs to say, okay, we customize the response. So I want, in this case, I want a full response. In the other case, I want a simple response. And that can be done. Of course, we need to implement. If we need it, we can implement different variants of the same information, the same query, that return data in a different way. It's the same data, but we can customize the format. Or the other possibility, it could be to have a limit, no? Users, limit to 10. For example, if I have a long list of users, just give me the first 10. Or the sorting order. I don't know, okay? We make our own rules. It depends on what kind of access we want to give to the data which is stored in the server, so that the application can use that. we are still in an abstract way, okay? We have some data, we are imagining how other people want to use this data and what are the formats in which we can provide them. If I imagine that I have a very large website, probably I would never have an API that returns all the users if there are 2 million. You never want to do that. So you will always have different ways of returning a subset of users, maybe, of resources. And you can control them with some options on the get collection. Get collection means give me a list of, and this list can be customized in some way. Okay, so actually, and the difference is that in this case, the 2 is the identifier of the element. And the other cases, these question marks are customization of how this information is returned. How or how much. So this is what get does. Get, apply on a resource, returns. If the resource is a collection, returns the list in some way. If the resource is a single item, it should return the representation of the specific item. Again, here we could have different levels of details if we want, if we need them. Okay? Then, other HTTP methods. This is just for reading. We cannot modify anything with get. Okay? Post and put are methods that are in HTTP, were designed 30 years ago to save content on a website. The idea at that time was that, okay, I'm sending you a form or I'm uploading a web page that will be stored, okay, on the server. Now they are not used for that purpose anymore, but the idea is that post submits something, creates something new, adds something that we still don't have. So the semantics of post only makes sense on a collection. Post creates a new item inside that collection. Okay? So we are adding, it can only use, normally it's used only with collection URIs, not with item URIs, which doesn't make really sense. So in this case, we can have, if we had the URI for the collection of users, what can a post do? A post will create a new item in the collection of users. Okay, what item? With what information? Well, post normally has the request for a post has a body. So the description in JSON of the object that we need to create, of the user that we need to create, will be inside the request body. So in this case, the request body, post request body, will contain the JSON representation of the new user that we want to add. Maybe, except for the ID. When I'm creating a new item, I don't know the ID yet, okay? The client has no way to know which is the next number available for them. It's always the database that atomically creates the new item that knows the ID that, well, maybe with an auto-increment method has been assigned. In this case, okay? They are auto-incremented IDs, so only the database, the moment in which it does the insert, it will create the ID. Never try to guess what the ID would be, okay? Because otherwise two different clients could guess the same number and have a conflict. So in this case, so maybe we have it's the body of the request, so we must send a post with the representation of a user. So it will be name, will be a new user, new guy, and the email will be the last one, gmail.com, whatever. Oh, that's why it wasn't highlighted. I don't know why it highlights the code here, but didn't. Okay, never mind. This is what I wanted to be highlighted. Okay, so I'm sending this information in the post request body, and what does the server do? We must implement that, of course. The server, if I have the permission to do that, it will create a new user. So this is the action for registering a new user, actually. Okay, and the server stores the new users and returns the confirmation that everything went well, or an error message. Okay, an error message. Let's do the good case first. The confirmation of successful operation with the maybe ID just assigned. Or with a full representation of the just created users. So how would the response from the post look like? It could be an error. Okay, let's see it in a moment. But if it's not an error, it could be, for example, one option could be just a number, 5. This is a valid JSON file. Or maybe we want to be more explicit. We will return an object that contains the ID to 5. The same information, but it's easier to read. Or we can return the full representation of the object, in this time including the ID. So it would be actually this information plus the ID itself. Again, our choice. The semantics is the same, the details, of course, should be designed in the specification. Of course, everything is done in levels. So first we need to decide which operations we need, and then we will go down and specify the details of how they should work. Or maybe also nothing. Okay, I just said I return the ID, but maybe it's not needed. I just need a confirmation. Okay, so it will be an empty body with just a 200 code HTTP return code saying, okay, everything was right. In general, I mentioned here with post because a post could fail. Okay, getting some data in the worst case doesn't return you anything, or but asking for some operation can create some errors. So let's mention it here. In case of errors, the server will generate an HTTP error code, for example 503 or something like that. Let's find an HTTP that matches what we are doing, with possibly, optionally, a response body containing the cause of the error. Okay, something went wrong, I tell you what. And the cause of the error could be just a string or an error object. They may have different fields if we need. Again, we decide what kind of information we return, we document it so that the user of our APIs know what to expect. Of course, encoded in JSON. So the client that calls the application knows that if they get a 200 error response code, the operation was successful, and they should expect something like that in the response body. If the return code is 500 or something, then the caller application knows that the operation went wrong, and they should expect some error information in the same response body. So it's a way of transferring exceptions through different applications. Remember, I have a database, I make a query, the query generates an exception. Okay, what do I do with the exception? The server, the HTTP server, will return an error code in HTTP, and this error code will travel with the response to the client, and then we'll see, okay, this was not a successful operation, let's throw an exception on my side, and let's try to handle that. Right now, we don't have the client side yet. But in any operation, we should also plan for how that operation could fail. And this was the post. Put is a verb, is a method that was designed for updating something. Okay? We use put for updating some information that is already there. We replace, okay, some existing information with a new version of itself. We don't create new information, we just update what we have there. Okay, so imagine a user needs to change their email address. The user ID remains the same, the name could remain the same, the email address will change. We are not creating put a new user. We are just updating the information of an existing user. Okay? So in this case, let's imagine that guy, number 2. We want to have a put on that address. So just notice, in the case of post, the address is always the address of a collection. I'm adding something to a collection. In the case of put, the address is always that of a single entity. We are updating that specific item. Updating a collection would mean, semantically, throwing away all the elements and recreating it from scratch. Seldom useful. Okay? So we tend not to use it. So in this case, the operation, a put on an item address, means update part of the object. Could be normally one or more properties, but normally not the ID, because the ID is there. The object number 2 is the only way that I can identify them. So, okay. With new data. And where is the data coming from? From the request body. Okay? Stored in JSON format in the request body. So in this case, for example, I will have, I could write that we have a representation of the email that we want to change. So we had an issue with this former email. Sorry, I deleted. Sorry, Control C. I want to change the email. Whatever. Okay, so that's one way. We only send the fields that need to be updated. Or we can send all the fields of the object. Some of them could be equal, some of them could be modified. It depends. What do we require? What is simpler to implement? Or what is more useful to implement? So one possibility, okay, in the first case, we just send the data that needs to be changed, and so the server will update the database table only on that column, or we provide all the data and they will be replaced all the time. So some of them could be equal to the previous version, some of them could be changed. Or maybe we can also send the full objects, also with the ID. And basically, this ID is redundant, of course. We already know which object needs to be modified. And technically, I don't want to modify it, okay? It must be true. We cannot say anything else here, because otherwise we will lose control of the specific item. Why I'm making this example? Because maybe in your code you already have some user object, and so it's easier to serialize that object instead of just serializing an object with all the fields except that one. So sometimes just for convenience. Okay, I already have the object in my code. I just send in that object itself, even if some fields are not expected to be changed. In a way, we say, okay, what we could say is every time we have a user object to transfer back and forth, we always use the same format. Even when we created a user before, okay, we could also have said, okay, but this is not an object of type user because it lacks one field. If I create a new user, I will always have also the ID. No? So I could also maybe add an ID, which it will be maybe an empty string or something like that, because I don't know it yet. But if I want to transfer objects which are always the same type of object, always with the same fields, okay, we know that in some contexts, some of the properties are not valid. I'm not writing undefined here, because undefined is not, can be null. Undefined is not one of the valid values in JSON, okay? But it could be null. Okay, why not? So there are many details that we need to fix in our documentation, in our design. Okay. Okay, you know that all this can be. Sorry, there's one last operation that is delete that I try not to talk about because I don't like it. Deleting data always makes me uncomfortable, okay? Especially because when you delete something and then next month you have your boss telling you, can you give me a statistics about what happened? Oh, I deleted everything. And you don't look nice in the eyes of your manager. And deleting for me is marking as deleted. If I want to do something to disappear, I will just add one field in the database, valid or active or deleted, and flip that data. The data never goes away. Okay? We are not short on kilobytes. Okay? So my suggestion is always think twice, or at least, before really deleting something, because you will need it later. You will need it later, for sure. Okay? But if you really want, of course, delete could be used onto an item, URL, and that deletes that row. And then all what happens in the database is the deletion if you have a foreign key that points to that object will propagate also to the other linked tables, yes or no. You have a lot of trouble when deleting something. Or delete on a collection is the worst that you can do. Will delete all the semantic will be to delete throw away all the elements on that collection. Okay, not something we like. Okay, so this is a small table that reminds us of the interaction between the URI that represents a collection or an item and the verb, the HTTP verb that we can use. So actually what we did is to use a syntax that exists, URI, some method that exists in HTTP, get, post, and put, and add the new semantics on them. So right now here we are not talking about HTTP anymore. Post, get, sorry. We are not talking about HTTP anymore. We are talking about application endpoints. This command, and then we learn to read it, is add a new user. Okay, and so we have a uniform way of reading, of interacting with the websites that use the same convention. And a lot of websites today are using a similar convention like this. As I mentioned, there are thousands of little variations on that. Okay, but the general idea is that we are not representing. You could have a different way of thinking. That could be, okay, let's create a create users endpoint. HTTP, whatever, create users. That would represent the actions that you do. Okay, so sort of remote procedure call. As a paradigm, as an architectural way of thinking, okay? And in that case, that would list all the operations that we can do and map them to a verb, to an endpoint that contains a verb. Normally, in the web application, we don't do this. We use nouns to represent entities, and then the operation on them is associated to HTTP actions. Okay, so it's a different way of thinking. Okay, I want to create a new user. Okay, let's do the create action on the user object or the user collection. It's people that were accustomed to working in Java, for example, not JavaScript. Distributed systems tend to think in this way. Okay, I have a method and there are some endpoints to call that method. And but actually it's a different way of thinking, of designing, okay, the interface. Of course, there are some. Okay, we can generalize, and this of course is the same. You see, this table here is taken from Google. Says, okay, we didn't invent everything. Is the years of work in web application that brought us to this set of conventions. And we see that in our example of the question and answer and so on, what we did for user could also translate to question, where we can add a new question, add a new answer, and so on. Add a question, search for question, get the list of them, and so on. So instead of user, the collection could be question, the collection could be answer, and we could do the same. With one complication, one added issue is that a question refers to a user. So we don't have just data, or we also have a relationship between data. Users don't have any relationship, they are just data. But a question cannot exist without a corresponding user. And even more, an answer could not exist without an author of the answer and the question that was answered by it. So, of course, databases have relationships in them. So how do we represent them? First question. Second question, the score. We have, in our mind, we have the idea of voting an answer. That would increase the score. We don't probably want to say I am updating the score. I want to say I'm voting the answer. Okay? So maybe in some cases I want to map some operation which is not just accessing the data and modifying and updating it. Maybe I want to update it with some rules. You cannot just replace your score of 5 with another score of 25. No, you must have an upvote for different users and so on. So I won't let you update your score so easily as you could update maybe your answer because there was a typo. There is some controlled way of accessing an object. So not everything can be mapped into these nice tables, put and get and post. And we see that. Okay, so there are two issues: relationships and extra operations. Relationships. Again, first we need to understand how to represent a relationship in the URI scheme, and then what actions we can do with them. The convention says normally try to add a third element to the URI. An item is mapped to some other list of items through a relationship. So let's say students is the list of all the students. 1, 2, 3, 4, 5 is a single student. Slash courses represent the relationship that the user, that specific student, has with the list of all the courses. Slash courses represents all the courses in the university. Students number courses represents the subset of courses of that user. So we qualify a collection with an item, or we expand an item by specifying a collection that is related to them. And it's a powerful way of seeing things. Okay, I have an item, and I know this item is in relationship with some courses. Okay, let's see what are these courses. And this will be a collection of courses. And as a collection, I could do all the operations. I could get the list of courses that I am enrolled with. I could add another course. I would enroll into an existing course. I could unenroll, delete one of the courses, and so on this collection. So actually, every item could expand into a collection of related items of different types. And this goes both ways. Courses slash a code. Courses represents all the courses in the university, slash a code represents a single course with all the information about the teacher, about the name and whatever. Slash students represent the collection of the students that are enrolled in the course. So the same information from the other way around. We don't need to decide in which way to navigate, we want to navigate data structure. We can represent it both ways. And we can, in our example, what does it mean? We could use, for example, we have questions, are the list of all the questions. Okay? User 2 questions would be the list of all questions by user 2. And this is a collection. And if it's a collection, we can do the actions that we normally do on a collection. So we can do a get, we can do a post. Get retrieves me the list of the question made by that user. Give me the list of questions made by that user. And here I will create a new question for that user. So I am a user, I am adding a new question to my list of questions. Okay? Which is a cleaner way, but we could also do post questions directly. In both cases, we are adding to the list of questions. Of course, by specifying that the author ID was 2. So I want to, it depends on how I want to represent it. Semantically, I could say, this is very explicit. I'm adding a new question to the list of questions for this user. No doubt. This post questions is more general. I'm adding a new question. But the relationship with the author of that question is not explicit. Of course, it would be implied by the content of the question object. It needs to have a, where is that, the question object, author ID field. And that will be the ID of the author that question will be assigned to. Okay? So there are two ways of saying the same thing, depending on what we want to implement. If you want to stick with this view or to the other one. And so these are collections, so the two operations that we can do on this URL are just a get or a post. I don't want to delete all the questions for that users. I will want to replace with put all the questions to that users. Put can only be applied to items. And if I want to, of course, when I create a new question, that will have a new question ID, okay? An ID for the question. Of course. If I want to represent, let's say, will be 15, okay? Let's imagine. So what if I want to have the information for getting, for reading, or for modifying, for example, that specific question? We could think something like this. from the list of questions of user 2, pick the one with the ID equal to 15. Actually, is not needed, because 15 is already an identifier for a question. You don't need to specify where it comes from. So this representation with 3 fields, collection, item, relationship, is enough. You don't need to go further. Because if you need to add another identifier, that would be unique by itself. It doesn't need the context on it. Okay? So you don't need to create many other methods, because the only, the 3 levels are normally sufficient for everything. Let's write it. Okay, so we can navigate relationships. We can navigate, we can update relationships. Okay. We can also see it on the other side. Question to what is the author. So let's see how we navigate the relationship in the reverse. Let's say question 2. And imagine I try to read it. What should I return? The representation of question number 2. Okay? What I will get is the object representing the question. And it's made of an ID, we do 2, of course. Then I have the text of the question, which is blah, 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 JavaScript something. Then I could have author ID and date. Which in this case the author ID is 2 again, and the date whatever. There is no date type in JSON, so we need to use strings for that. That's one possibility. And if I need to get information about the user, again, I have different options. One option is okay, I need, because maybe you want to show the question and you need to show the name of the user. Question blah 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 by name and full name, not just the number. Okay? So in our front end you need this information. You don't have it here. So what you could do to have the information about the user, what we could do is to get users do. We have the ID, we get the information. An extra call. We have a call for the data concerning the question and a call for the data concerning the user that we need to show. And probably would also I will also want to display the list of answers to this question. So there will be maybe also getting the list of all the answers. Get questions to answers. The answers that are linked to this question, which is a collection. So, okay, but this is about the answers. Or we can decide that the information about the question doesn't just include the author ID, but it could also include the information about the author as a full object, nested. So in this case, it would be, I already have this, 3 fields. No? That could be an option. Whenever in a table I have an external relationship, I could return the ID for that relationship or expand and go get the data which is referred to. Again, it's a choice. If I know that this information is always needed, it's faster if I provide it right away. Otherwise, I just provide the ID, and if the application needs, I can always get the data about the user. So again, it's choice, it's a design choice. We must think what we return, what we want to return. Comma. Yeah. What is wrong? What would be wrong? Okay, was to say something like get questions to users. This is wrong because we have only one user for a question. Okay, it's not a collection of users. So this would be misleading. No, because users, the author is only one and is not a collection. Okay? When we have the 3 segments, the third one should be a collection. It doesn't make any sense to ask all the users for question 2. No, we only have one, and the information about the user is already inside the object. So the relationships are useful when the relationships are too many. One too many or many too many. Okay? If the relationships are to one, you just use the data, the property of the object itself. Okay, of course, for every rule that I told you today, there can be exceptions, okay, depending on the needs of the application. But this is just the general way of thinking. And so the same, if I want to create an answer, how would you do it? How would you do it? Create him in post into a collection of answers, like this. One possibility. Then what is the question or the author of that answer will be inside the representation of the data. Or maybe it's more explicit, say, okay, I want to add a new answer to question number 2. So this would add a new answer and explicitly connect it to question number 2. Or do we like this one? Users to answers? I don't like it too much because it doesn't make me explicit which question I'm answering to. Oh, okay, of course, it would be in the body of the object that I'm sending, okay, the idea of the question. But it looks like I'm making an answer to I don't know what. So personally, I would prefer this one. Technically, either of these could work, because all the information which is not in the array will be inside the object. But it's just for clarity. Just imagine that we are designing an interface, an API, so that others can understand it easily and use it easily. So the more explicit we are about how the objects connect with themselves, the better. There's no right or wrong. Yes, a design that is complete and easy to use. Last point, and then we make a break, and after we start implementing some of this, just to see. Devoting, for example. So operations outside the grid of the standard ones. How to represent a vote? For example, operation. One possibility could just updating. Put answer 3, and then in the body we could have the new vote itself. Score, it's called score if I remember correctly in the database. Answer score, yes. I don't like it. It's dangerous because the client would decide the score that they get, change it to something else. Okay, the score of a social answer is not a big issue, but if it's you know, the money in your account, you wouldn't let anybody just set a new value and store it instead of the current one. You want to have a controlled way of that, of updating that. Okay, so not just store this data, but have some logic on the back end that decides whether this data is correct or not, or does other kind of checks. But even if you are honest, we should always consider the fact that there are concurrent users to our application. So imagine there are 2 users that really like your answer. Your answer is scored 9. So the 2 users will see on their browser score 9, score 9. Oh no, this deserves better. And both users click on vote. What happens on this application? That it would say, if I had this kind of API, the application would call put score equal to 10. But also that other guy would click on vote because he likes my answer, and that browser will send an update with put score equal to 10. But the real score should be 11 because I have 2 upvotes. So what happened is that the 2 clients try to update some information, but they didn't have the latest value. They had a value 9 which was old. It's not current. So when computing the new value, they're relying on an out-of-date version of the current one. And this could create loss of data. Okay? So never let clients update information which is stored in the server. If the update, say, needs the old value to compute the new one, if it's really an update. Now, if it's just a replacement, like we did with email address, no issue. But if we need the old value to create the new, do that in the server, always, never in the client. And so the operation should be semantically what we need to do, create a new vote. So I would say probably post answers 3 vote. semantically, this answer, number 3, has a list of votes. I'm adding a new vote for it. Do we really have a list of votes in the database? No. Never mind. The idea is the same. Since we don't record any information about the list of votes right now, we don't need the list of votes themselves. We just decided to have a score, which is the count of number of votes. Okay? But we could imagine for interpreting this, that we have many votes and I'm adding one to the pile. And the server will count them. The request body could contain nothing, or could contain maybe the value of the vote. It could be a +1 or -1, for example. So in this case, we are not ambiguous. We are adding a vote to that item. Does adding a vote just increment a counter, or adds a new row into the table? Because maybe we want to record the date in which that vote was added, or the user who added these votes. If we need to record them, we can just modify the database, we can modify the implementation of the server. We don't need to modify the API at all, because the semantics is all there. Okay? So always try to think about what you are doing with the abstract representation of your data, rather than the concrete query that you need to do on the data itself. Because also gives us the possibility of evolving the database also after, and representing in a higher level. What we will see, for example, in the next week, when we see how to integrate the authentication into the server, we will do this trick again. For example, for login and logout. Okay, login and logout are actions, but for representing them in this way, we use some abstract object called session. So we would have the login action would be create a new session. So we use a session that doesn't match any. We will see it next week. Doesn't match any object in the database, but conceptually, it will open a new session in which this user is logged in. And when I want to log out, I would just delete this session. And if I want to get the current session, so what is the user currently logged in? So this pattern is more powerful than just representing tables in the database. It represents in an abstract way entities and collections, and the operation of this collection can be mapped to different kind of semantics of backend operations. Okay, so always think that the design of the API right now, we are just imagining how to provide access to the data that we are storing. We still don't tell the specification of what kind of application we want to build. So we don't have a guide for saying, is this choice better than that? We would need to also have the understanding of what happened on the front end, or what do we need on the front end to do that. But the design of the API, I think, is one of the most important parts in which you are really understanding what this application can do, independently of how you can implement it on the database, or how you can use this operation on the client side. I usually, just to tell you, the first thing I discuss with you at the exam is the API, because that reveals a lot of how you think about your application, about how you made some kind of choices, which operators are done on the client, which operators are done on the server, and so on. Okay, so it's easy from an implementation point of view, but it's a design step that you shouldn't just do randomly, but it puts the foundation to the architecture of your application. Okay, I talked too much, so let's make a break, and then we write some code together. Okay.